Assalamu alaikum and hello everyone. This lecture is about scenario analysis, and we use this analysis where we have different scenarios and we need to compare the risk and return of the project. We are using Fundamentals of Financial Management by Brigham Houston, and this lecture will cover problem 12-7. Here it is. So, the industries is considering a proposed project whose estimated NPV is 12 million. So this is estimated NPV, it is given. And this estimate assumes that economic condition will be average. So NPV is 12 million and this 12 million is on the average economic condition. Here you can see that average economic condition has 12 million NPV. Then the CFO realizes that the condition could be better or worse, so she performed a scenario analysis and obtained these results. Based on scenario analysis, you can see that different scenarios are there. We have 5 different economic scenarios: recession, below average, average, above average, and boom. So these are the 5 different economic condition or 5 different economic scenarios. Based on these economic scenarios, the NPV is also given. When the economic scenario is recession, then NPV would be negative, which is minus $70 million, then minus 25, and then increasing when the economic condition is improving from average to the boom. And these are the possibilities of outcomes, or you can say probabilities of outcomes, which are 5%, 25%, 50, 20, and 5%. The requirement is to calculate the project expected NPV. So first is project expected NPV. So these NPVs are different NPVs at different economic scenarios are given. But the requirement is to calculate project's expected NPV, which is also known as you can say the average NPV, and it is the mean value of probability distribution of all possible NPVs or all possible returns. So now what we are going to do, we are going to calculate expected NPV. And the simple way is to calculate expected NPV is to multiply the return of individual scenario, means this one, and with their expected probabilities. So J3 multiplied by K3. So when we add all of these, because you can see the sign of summation in the formula. So now we are going to sum all of these. So this is 3 million, or as all these amount are in million dollars, you can see. So this is 3 million. This 3 million is expected average NPV, or you can say uh, we have calculated this amount, or this 3 million is the mean value of all possibilities of different scenarios. So here we are going to highlight it. The second requirement is standard deviation. So it is the measure of the dispersion of possible outcomes, or this represent risk. So you can say the greater standard deviation, the greater the uncertainty and the greater risk. So here it is the formula is for the calculation of standard deviation, or you can say for the calculation of risk. So in the next step, what we are going to do is to take the difference between individual NPVs with the average NPV. So here what we are going to do, we deduct NPV with the expected NPV. So expected NPV is same, which is uh, 3, which we have calculated 3 million. So here NPV is K3. So K3 is going to be multiplied by minus by 3. So this 3 remains constant as it is the average, you can see. So, and then we take square root of these two. So here we have eh, NPV minus ENPV. ENPV means expected NPV, which we have calculated as 3 million. And then we take square root of it. So here we have 3 n square. And then we multiply it by the probability. So here it is probability is given. So we multiply this column which is n. So we are going to multiply n3 with the probability under each scenario 3. So here we apply it under each scenario, and then we take square root. You see the sign of square root. So we add all of these, which is summation. And now standard deviation is the square root of NPV minus ENPV square, hat and square 2 with their probability. So here we can use the Excel sheet with or the built-in formulas. Here we have this square root. So square root of this amount. Okay. So 23.622 is the standard deviation, or you can say this is the risk, which is 23.622%. And then the next requirement is coefficient of variation. Coefficient of variation is the risk per unit of return. So coefficient of variation, you have a risk, which is a standard deviation, divided by expected return. So expected NPV is there. Here we have standard deviation is 23.622 divide by here 3, which is the return. So answer is 7.78 times. This means that the risk is 7.87 times as compared to the return. Or if the return is 1 time, then the risk is 7.874 times. So here in the scenario analysis, you can see that we have different scenario analysis, and we have different economic scenarios, and for each scenario we have different NPVs and different possibilities of the outcome. What we did is to simply multiply each of these, that NPV with possible outcomes, in order to get expected NPV, which is the average NPV, or you can say the mean value of all possible return. The next step or the next requirement was to calculate standard deviation. Standard deviation formalized this one, where the individual NPVs are, we deduct average NPV from the individual NPV, then take the square root of it, and the difference, take the square root of the difference, and then we multiply it by the probability. So here we have calculated this amount, which is 558, and in last we took the square root of this, and this is square root. So this standard deviation represent the risk of the of these this project. This is the average, you can say, risk by considering the probability or possibilities of outcome under different economic situation. And the last thing was a coefficient of variation. This coefficient of variation represent the risk per unit of return. So that's it from this problem. Take care, class.